Third and last example for simplifying radicals. I wanted to give you one where you have a negative exponent inside a radical so that you can see what you need to do. Anytime we have a negative exponent, you have to follow the law of exponents, which says that this law of exponents says that whenever you have x to the negative 1 power, that's the same thing as writing 1 over x, and then that exponent becomes positive. Or if you have x to the negative 3rd power, it's the same thing as 1 over x cubed. Okay? That's what the law says. If it's in the numerator and it's a negative exponent, you bring it down to the denominator. If it's in the denominator and it's a negative exponent, for example, let's say I have 3 over x to the negative 2 power. This exponent is negative in the denominator. I can make it positive by bringing it up to the numerator. Okay, so it's switching places. If it's negative in the numerator, bring it down into the denominator and it makes it positive. If it's negative in the denominator, bring it up to the numerator and that makes it positive. But we always want positive exponents. And let me erase this because I'm going to need this space. Okay, so having said that about negative exponents, I can rewrite this radicand. I'm going to rewrite this radicand as 24 x to the 6th power, and then y to the 4th power comes to the bottom, to the denominator, so that I can have my exponent positive. And remember, we still have the square root of all of this. So it's the square root of a fraction. Okay? And now I'm going to solve this the long way, like we did in the previous video, and then I'm going to do it the short way. So let's do the long way first. I have a numerator and a denominator. They're all inside this radical. I can separate the numerator and the denominator like this. I can separate the radical in the numerator and the radical in the denominator. Okay? And then I'm going to work in the numerator first. I'm going to separate these two factors, the 24 and the x to the 6th power. I'm going to separate into separate radicals like this. Square root of 24, square root of x to the 6th power, and the square root of y to the 4th power. Okay? And let's continue down here. To find out the square root of 24, remember, I need to make a list. I need to make a list of all the factors for 24. That's 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 times nothing, and 6 times 4. Once I repeat a pair of factors, that means I'm done with my list of factors. Now, out of these pairs, I'm going to choose the one that has a perfect square, and also that it's the largest perfect square. So the only perfect square I see out of these 8 factors is 4. So I'm going to rewrite 24. I'm going to rewrite 24 as the square root of 4 times 6. And since this is a square root and I have x to the 6th power, I'm going to rewrite this as powers of 2. That's x to the 6th. Remember, you want to match your exponent to your index. This is a 2 here. And in the denominator, I do the same thing. I'm going to rewrite y to the 4th power as y to the 2nd power times y to the 2nd power. And then we're going to continue here. The square root of 4 times 6 is the same thing as, this is the same thing as the square root of 4 times the square root of 6. So this becomes 2 because the square root of 4 is 2. Square root of 4 is 2. And the square root of 6 I keep because I can't simplify 6 any further. The only factors for 6 are 1, 6, 2, and 3. And none of those are perfect squares. So that means that the square root of 6 is already simplified as much as it can be simplified. And for these here, remember, I can separate these into their very own little radicals. I could have x squared, x squared, x squared, and in the denominator I could have square root of y squared, square root of y squared. Then I have 2 square root of 6, and out of each of these radicals comes out an x, right? Because I have x squared, the square root of x squared. And we had said before that the square root of x squared is the same thing as x to the 2/2 power, which is x, if we change it into a rational exponent expression. So that means that this is x, this is x, and this is x. Remember, this is all multiplied. And in the denominator, I have y and y. Finally, this comes out to be x cubed, x to the 3rd power. So this is 2 square root of 6, x to the 3rd power over y to the 2nd power. And we're going to reorganize these terms here, because when we write rational expressions, not rational expressions, when we write radical expressions, you always see the radical at the end. Okay, so we write our coefficients in front, and then come our variables, and at the very end we have our radicals. So I'm going to rewrite this as 2x cubed square root of 6 over y squared. And that would be your final answer. Now the short way. Let's do the short way. For the short way, you take your original expression. I'm going to rewrite it down here. 24x to the 6th power, y to the negative 4th power. And this is what you're going to do. You still have to, for your first step, you still have to, let me separate this. You still have to, for your first step, rewrite this as 24x to the 6th power over y to the 4th power. You still have to write that exponent as a positive exponent in the denominator, okay? And now this is what you do, square root of 24, and I'm not going to go through that again because we did all of that. We already know that's 2 square root of 6. Okay, x to the 6th power, we take the 6, we divide it by this index or by this root, which is 2. So what comes out is going to be x. 6 divided by 2 is 3, so that means it's x cubed. Okay, when I do this division, 6 divided by 2, the answer, which is 3, that's the exponent of the x that's going to come out of the radical. And in the denominator, I do the same thing. I have 4 divided by 2. That gives you 2. So 2 is the exponent of the variable that comes outside of the radical. And notice that I get the exact same answer with much less work. And here, remember to reorganize this. And there you go. I hope you understood this example. This is the last example for simplifying radicals. Make sure you practice. This takes a lot of practice.